Statistical analysis, such as regression modeling, can often be framed in terms of an overall task, analyzing data to inform a decision. We're going to assume that we've collected data that's relevant to the problem, and in this chapter we're going to focus on the intermediate task of identifying and summarizing the data. And the example that we'll use throughout this chapter is moving to a new city and wishing to buy a home. And we're going to use a data set of n equals 30 randomly sampled single-family homes and just one variable that we'll call y, which will represent the selling price in thousands of dollars. So here we can see a list or a table with all the data values, all 30 of them. So this first one represents $155,500, the next one $195,000, and so on, all the way up to $359,900. So we could think about summarizing that data graphically, and one easy way to summarize the data graphically is to use what's called a stem and leaf plot. So here's an example for the home prices data set that we just looked at. The way that we construct this graph or plot is to look at the highest place value for the data values. So that's hundreds in this case, and that's going to be represented using the stem. So on the left hand side of the stem and leaf plot we have the stem with the 1 representing 100, the 2's representing 200, the 3's representing 300. And then in the leaf we write down digits representing the next place value. So for example, this 6 here would represent 6 tens. So for this first observation in the data set, we've got 100 and 6 tens, so that would be $160,000. And the numbers here in this case represent numbers rounded to the nearest 10. So this 6 at the top represents a house price between $155,000 and $164,900. If we look back at the data, it's this house here, the one that sold for $155,500. And then this next one, the 0, that's going to be a house price between $195,000 and $204,900, and so on all the way up to these 6's here are going to represent house prices between $355,000 and $364,900. So the purpose of summarizing data graphically is so that we can get a better sense of the distribution of the data values. And so here we can see that they range from $155,000 up to $365,000. It's a fairly symmetric distribution, and maybe the average value is somewhere in here, maybe $270,000, $280,000, somewhere around there, and the individual values are evenly distributed around that average. So another way to summarize data graphically is using a histogram. And so here's a histogram for the same data set. And again, we can tell a similar story from the histogram. Here we've got bars representing the frequency of data values within intervals. So this first bar is going to be between $150,000 and $175,000, and then there's just one observation in that interval, and then there's 2 observations between $175,000 and $200,000, and so on, all the way up to this final bar represents 3 houses that sold between $350,000 and $375,000. So I'm going to demonstrate how to create graphs like this using statistical software, and the software that I'll use to demonstrate this is R. And so I've got R open here inside RStudio, and I can read the data, and then I'll attach the data frame, and then I can create a stem and leaf plot using the stem function. And so down here in the output console we can see the stem and leaf plot that we talked about earlier, and then we can use the hist function to create a histogram. And so we can see over here in the plot window a histogram for this data. So that's a couple of ways of summarizing data graphically. Let's now think about summarizing data numerically using sample statistics. So one example of a sample statistic is the sample mean, also sometimes called the arithmetic average, and that measures the central tendency of the data values, the y values. And we're going to denote that with m subscript y. Another way to measure central tendency is using the median. And the median, the way that we calculate the median is to order the data from lowest to highest, and then if there's an odd number of observations, we can just pick out the middle one, and that will be the median. If there's an even number of observations, there's going to be two numbers in the middle, and we would take the average of those, and that would be the median. And one difference between the median and the mean is that the median is less sensitive to very small or very large values in the data set, whereas the mean can be overly impacted by either very small or very large values. It can make the mean look too small or too large when it's supposed to be measuring the center of the distribution. So those two sample statistics measure the central tendency of the data. If we're thinking about the spread or the variability in the data, then we would look at, for example, the sample standard deviation. And we are going to denote that with S subscript y. If we were to square the sample standard deviation, we would get the sample variance. A couple more sample statistics, just the smallest and the largest values in the data set, the minimum and the maximum. And then another type of sample statistic is a percentile. So for example, the 25th percentile will be the number such that 25% of the data values would be smaller than that number, and 75% of the data values would be larger than that number. And so we can calculate any percentile, so the 25th, the 50th, the 75th, the 99th. If we think about the 50th percentile, so if we just think about that for a second, so that's going to be the number such that half the data values are smaller than that number and half will be larger than that number. So if we think about it, we can see that we're just talking about the median there. So another name for the 50th percentile is the median. So going back to R, here's the code that we can use to calculate those summary statistics. And I just want to focus on the percentile calculation. We actually use the Quantile function to do that. And you can see that there's an additional argument here, type equals 6. So to see what that refers to, I'm going to use the help function in R and look at the description of the function, and it's got a type argument here. The default value is 7. We set it to 6 here, and we can get information on what the different types are just by scrolling down. And there's type 1, 2, and 3, and then 4, 5, and 6. So this is the one that we used. So we're using the same one the same method that's used by Minitab and SPSS. The default one that I use is actually type 7. So technically these are all slightly different, but we're not going to worry about the precise details here. Just know that you can obtain different types of quantile calculation depending on what you're choosing as the type. I'll finish this video by talking about standardizing data. So standardizing means to calibrate the data so that it has a common scale. And the way that we're going to do that is we're going to take our data represented by the letter y, and we'll subtract the sample mean, my, and we'll divide by the sample standard deviation, sy. And that's going to create a new variable that we'll call z or z. So if we do that, we're going to have a new variable with the same number of values as the original data. And if we were to calculate the sample mean of the new variable, it would have a mean of 0. And if we were to calculate the sample standard deviation of the new variable, it would have a sample standard deviation of 1. And so that's what I meant up here when I said that standardizing is calibrating the data to a common scale. And the common scale means that it has a mean of 0 and a sample standard deviation of 1. And so this is a good way of taking any data set and recalibrating it so it has this common scale. So we can see how to do that in R. So here, this is my calculation for standardizing the variable price. I'm subtracting the mean and dividing by the standard deviation. So I can run that, and then just to demonstrate that the mean of the new variable is indeed 0. So you might look at this and go, well, that's not 0. Well, it's pretty much 0. It's minus 4.678043 times 10 to the minus 16, which is a very, very small number that's essentially 0. The reason it's not exactly 0 is because R is doing calculations here to a certain precision, and the best precision it can get here is such that the calculation for the mean of the standardized values isn't exactly 0, but it's essentially 0. The standard deviation, though, when it does that calculation, it does actually get 1. So I've talked about a couple of different ways of summarizing data graphically using a stem and leaf plot and a histogram, and then I've shown a few different examples of sample statistics such as the mean and the standard deviation, and then I've also talked about standardizing data.